Now, I'm very pleased to say that Florence has a phonograph cylinder on which her voice will be recorded, which is driven by a series of complicated pulleys on a pulley and a little engine, as we like to call it. This is all going to feed the sound of her voice via a special vibrating system. So that comes out of the cabinet, up the side of the cabinet, and ends in a beautiful brass horn which looks lovely on the outside of Florence's home. Time to start thinking about audio. How can I make Florence actually speak? Now, with a laser cutter and a 3D printer, it might be possible to engrave on the laser cutter a type of record that could have a stylus that actually played it mechanically. No, we are not going to do that. That might be another project for another time. What we're going to use, one of these little boards from Adafruit, who make all sorts of accessories for the work with Arduino. This particular board has, I think it's 16 megabytes space on it to store audio files, and has all the necessary processing to be able to play them back in any order whenever you want, controlled where necessary by an Arduino. So that's really good. I am going to consider making the horn that's going to allow her voice out. I ordered this red plastic trumpet ages ago just as an interesting sort of aside. I then tried to prise it apart stupidly and found that the adhesive was actually stronger than the plastic itself, and I've split it at the top. So I'm going to have to try and sort out how to fix that. Right, I've cut the horn off and revealed the extent of the damage I inflicted. After a bit of investigation, I just don't think that that's going to look right. I think the horn is going to detract from Florence's head. So it's a shame, because I really wanted to make a 3D printed bend in one of these. So what I think I'm going to do instead is to mount it on this side and have the horn just over the top like that, and then it won't detract from Florence. Right, so I've got the support. I'm using a Munson ring for the top of it, and the bit I've turned down, which used to be a gas fitting of some sort, at the bottom. I was thinking, yeah, that looks nice. And then I suddenly remembered this old trumpet that I've used for different inventions, bits off, and I'm going to put the 3 buttons on the front of this machine. And I used the horn on the epizooscope. That this, near the bottom, has a little vent button, so if it gets filled with the saliva as you're playing the trumpet, you can open that and drain it all out, and I think that would look absolutely brilliant on the corner of my one. So I'm going to see about unsoldering this and gluing it on. How exciting! A 75 watt soldering iron, nice and powerful, bit of solder to transfer the heat across, and it's fallen off, which is great. Well, the paint's dry. I've cut out and sprayed a support for a little speaker, a loudspeaker. Here it is, really nice little one. It's got a very powerful magnet. It came out of an old plug-in PC speaker that I've used for other bits, the other one, so this was still floating around. So that's great, and also I managed to get a little amplifier out of it as well. So it'll be a really nice powerful speaker. That's going to sit on there. That's then going to sit and screw inside here, and we've got this bit to go on the outside, and then into that the horn will go, and the horn's sprayed, and So annoying. Inside there's little specks, and that's not from the paint, it's actually little specks of plastic that were part of the moulding, and it just spoils it. I don't like it when I've got this beautiful outside and people look in the top and they see a load of little bumps and lumps. So I'm going to have to sand that off with some wet and dry, respray that, and then assemble everything. There we are. I've sanded off all the little rough bits, and actually there were loads of little speckles and things all around this top part of the moulding, which is strange. So I've sanded them off with wet and dry, and it's really nice and smooth. Obviously, because I want Florence to be able to speak, speaking is going to be quite an important part of the mechanism. The horn is now painted and mounted, and that looks really nice. There's a little vent valve thing that you can push. Lovely, little red felt pad. And that goes through, and here's the remaining space inside the cabinet. I've made a large pulley which has got bearings in it and a support on the side. That uses one of these springs to link it to a little motor that runs round, and obviously having such a small pulley turning a large one, that slows the large one down a lot. What I'm now doing is working out a way to link this so it will turn this plumbing fitting. I was thinking about what I could use to represent a wax drum, like the really old recording systems, and this plumbing fitting is perfect. It's nice shiny black plastic. I need to work out how to get a slot or a groove effect on it. Either I'll put it on the laser cutter and turn it round while cutting a groove, or I'll use the thread cutting capabilities on the lathe. I think I'm erring for the second one. Should be possible, as my lathe's got a lead screw, to be able to put this on the lathe, get it turning, and then have the tool running along really quickly, cutting the groove. Now I want to put the synthetic wax drum somewhere like that. It's got to be far enough away from Florence's engine to not hit that as it swings round. It's really annoying that that stuck out so far. Never mind, the more design constraints the better. So I've worked out it needs to line up with that copper pipe that sticks up, sort of somewhere around here. Then I can have some sort of stylus fixed onto the back of the speaker so it looks like it is actually reading the tracks. And I also want some way of moving the stylus, because if it was a wax recording, as Florence says different things, it would need to move to different tracks. So that's where we're at the moment. So I've got some ideas drawn out, measurements taken for how to support this little plumbing fitting, and a little idea for twiddly bits to support the ends. So I'm just going to draw them into the computer and then cut them out. So much for having a series of well documented CAD drawings all labelled and numbered and dated. What I've ended up doing, what I do with all these machines, is start off with a little A3 sheet and start drawing bits on components, and then it grows. This is currently A1, so next step will be A0. So here we are. Here's a support for each end, just one turned upside down to save plastic. There's a nice end cap for the wax cylinder, and they would have been so proud of it they definitely would have had it decorated. There's the other end that you won't see, and the two pieces that are going to insert inside the plumbing fitting. After much fiddling around at the dirty end of the lathe, well, I say dirt, it's just lots of grease and lubrication, I think I have figured out, probably wrongly, but I don't really care about the measurements, I think I've figured out how to set these three gears to turn the lead screw, which is, come along here, this is the lead screw that runs along the front of the lathe, and that turns and can, if you wish, move the carriage along. And I want to make these grooves a spiral groove around this little bit of plastic, so I need this lead screw to go relatively fast. Because I've only got a small chuck and it's too small to grip this from the outside, I'm going to use the chuck back to front and support it from the inside. That has a couple of benefits. One is I can cut far closer to this end without hitting the chuck, which is good. Now that's going to be really wobbly and will probably fly off, but luckily, in previous project, I've got a bearing wrapped in piles of stuff and got the right size pipe on the outside that fits into this fitting. So I can plug that in there, support that on the headstock, end stock. I don't know, the more I learn about 3D printing, the more I forget other stuff that I've learned in the past. I'm going to fix that on there, and that will support this end, so I can then hopefully cut this slot groove. That's it. To cut the actual groove, I've ground down the end of a parting off tool to a nice little point, which can get quite close up to the chuck. I'll put that in the quick release chuck and we'll see how it goes. I'll quick release tool holder and see how it goes. Because I'm a chicken, I'm not using the motor. I've realised I can actually turn the chuck by hand, and it is moving along, making a really nice groove. The thought of putting this into as a power mode and having the tool heading very quickly towards the spinning chuck doesn't fill me with joy, so I think I'm going to be happy with this. So we'll keep going like this and see what happens. Oh, come on. Well, as before, all nice and shiny and grooveless, and here's one I prepared earlier which has got the grooves on. But I reckon when that's mounted in there spinning round, catching the light, it'll look like one of the old-fashioned, well, more like Bakelite records. I've got the two end pieces glued together now and drilled out, ready to accept the bearings, because I do seem to have the desire to use as many bearings as possible. I'm sure it's not necessary, but it's very satisfying. So I've drilled these bearings are 13mm diameter, so, and 5mm thick. So I've drilled a 13mm hole, not all the way through, just 5mm deep. So this bearing will sit in there. The same with this bearing. But the idea is that this then sits in there, and I can glue that in, and that will support it and allow it to spin. Before I do that, before I forget, this end is thicker. This is 5mm thick, because I want to put it on the lathe and turn a slot in it for a pulley. The tool I'm going to use to cut the groove is just got a rounded end, and I've lined it up so it should just cut beautifully. I want to glue this piece, which is going to support the gramophone drum or whatever, onto this end, and another piece onto that end, and a little top tip. If you don't want to ruin your beautiful table but you want to use a flat surface to line things up with, put a bit of packing tape down, because super glue does not stick to packing tape. So to prove that, I'll put some super glue. Oh, wretched thing. The nozzle keeps drying up. There we are, a new tube. By the way, I got these tubes of super glue for the Nempnett Thrubwell kitchen timer steampunk machine kit, which you may be interested in. Just visit my website and there are details there. Build your very own working steampunk machine. Let's put some super glue along the end, which I've roughened up slightly on the sand, and actually that's a bit much. I wouldn't recommend doing that, but just take a little bit off. Set that on there, and make sure we got this one in the right way around. Line it up. There you go. Push it together. Bob's your uncle, Fanny's your aunt. And it hasn't stuck. I know I haven't given it much time, just to prove. And you can see there's a nice, well, you can see it's a not bad glue joint along there, because there's crystal clear all the way through except to this end, so I might drip a little bit on just for your delectation. There we are. Oh, look at that. Is that daylight I hear you cry? I think it might be. It burns and is very unpleasant, but on a daylight day it is a shame not to let a little into the workshop. So we'll spray those. And as I've said in the past, I've found the best way to do it is just to turn them through 90 degrees. The danger always with spraying is if you put too much on too quickly, it will run, and it's so tempting to, because you want to see what it looks like and start spraying and it makes it look brilliant. But leave that, and this is a lovely spray, you leave it for 5 minutes and it's dry, and then you can put another coat on, and I've found a couple of coats will be quite sufficient. Now I've had my beans and I can't wait any longer. The paint is sort of dry, but it's so exciting putting something together. It's always tempting to glue it together first, but I think it's like doing decorating. If you don't do all the preparation first that no one actually gets to see, it's going to be hidden under the wallpaper, it looks rubbish. Right, here's my thing. So I'm going to glue that. Is there any particular way that I want that to be? Right, pop that in there. Around there. That in there. I see. Ooh, it's so nice when you put things together and you suddenly see the contrast in colours and the design and everything. That looks really nice. Well, I've got that fixed down and I'm just going to cut the drive shaft, and I was thinking, how can I fix it in? Luckily the front of it now lines up with the back of that vertical copper pipe. If I just push this in as far as it'll go, I don't need any complicated grub screws, because I can put a ruler across where the back pan is going, put a mark on it and just saw it off. I say, Governor, what a lovely twirly thing. Just so lovely when you've got bearings in stuff. So that spins beautifully now. So now I've got to work out how to get one of these, I'm going to say it properly, spring pulley things from here up to this centrepiece. I'm getting a bit dark, there we are, up to the centrepiece where there's a pulley cut. Round the centrepiece and then somehow back down to this side, or vice versa. I'm definitely going to need some pulleys. Let's see how I can do it. Perhaps I'll use those aluminium rods that I used last time, which were so helpful. I've got the major distances and angles worked out. So one was 60mm from the top and the other 100 and the 12 degrees and 7 degrees. So I knew whereabouts everything needed to go. What I've done is to use that to create the support for the two pulleys by simply measuring down. I started off by drawing out one of the pulleys with the marking on the centres of where the spring pulley is going to actually pass. Then I could set the angle, move them over to the point, the height and the distance, height and the width where they need to go, and then just build up the rest of the idea from that. The Victorians and other people working in metal and casting always used to leave holes where they could afford to for strength, simply because it would save on material, and it looks a bit odd with this one so far, but I think it usually adds a certain je ne sais quoi to the design, reminiscent of that era. Well, that's come out well. Don't know whether it's going to line up. We'll wait and see. What I've also done, if I zoom in, and see a little notch there, that's to let me know where to line up the 4mm drill bit. Because the pulley shafts are going through here, I want the wire fixing them in so that I can remove them if necessary. What I'm going to do is to drill a 3.3mm hole and tap into that so I can put a grub screw or a brass screw or something into it to clamp down on the shaft to hold it in place. What I thought of some time ago, and here's another top tip, is one of the little bits that fell out of the middle, these holes. I've realised I can glue them on the side, and that gives me far more plastic acrylic to be able to drill through to tap to support a thread. If you're tapping metal, like mild steel or something, you need special cutting compound, and you need to use a tap wrench, and you turn it a couple of turns back half to clear all the little cutting slots. And you do it like that, very slowly and gradually. So obviously the worst thing that can happen if you're tapping a hole is the tap shears off. And if the tap shears off, you're completely stuffed, because the hole that you've just drilled is full of hardened steel tap, and basically the whole thing you've made is ruined. Whereas, if I can keep this wretched thing into focus, what I've realised is you can put a little bit of rubbing alcohol, as we like to call it, on the tap, and I'm going to keep getting covered in everything. That just keeps the drill bit, the tap, a little bit cooler and stops it clogging. I'm going to try and keep this all focused. And what I'm going to do is just go in a bit out, in a little bit more. If you go too fast, it melts the plastic because of all the scraping that's going on. There you go. And now you've got a beautiful threaded hole. What I'll do is I'll screw this together and then get back to you with the good or bad news. Let's wait and see. The ends of the rivet here, you can see, are going to bang into the nuts that hold this large pulley together. So I'm not quite sure what to do. Getting rid of the nuts, I think, would be the best thing. I'll have a think about that. Having applied copious amounts of super glue to the outside rims on both the front and the back, which looks an absolute shambles, the super glue, if it finds any grease anywhere, any remotest hint of grease from a fingerprint or something, goes white, produces white deposits. It looks a right old shambles, but what I'm hoping is that once I spray it, it'll cover everything up. I then countersunk the holes, and with wonderful countersunk screws, as you can see, the idea being that the countersunk drill drills the same angled hole as the screw head. So you push that in, that nice and flat, rebated slightly because I didn't set the countersink, I just drilled it anyway, it doesn't really matter. I've got room at the back, there's nothing happening at the back, so that doesn't matter. So what I'm going to do now, before I put all the screws back in, I'm going to put it back together and see whether the pulley system works. This is so exciting. I've got a couple of wires soldered onto this little motor, and that's running that bigger pulley that's now not got any nuts sticking proud of it. So from the back we've got the big pulley turned by the motor, the little pulley in the centre pulling over these two, and that thing I cut out works perfectly. The spring is perfectly aligned, so the top one comes down there, round the back of the phonograph cylinder, and then back up, back to the original pulley. And it's turning. It's fantastic, so exciting. If you're interested in these spring pulley things, here's the information. The product number is NR00827, diameter 2.5mm, length 600mm.